In this video, I'm going to show you that limit x approaches 0, sine of x over x is equal to 1. To show this, let's consider this diagram. This is a unit circle, by the way. So this is a unit circle. And let's consider three figures here. Two are triangle and the third one is a pizza slice as labeled green here. So I'll clarify on that later. The angle is x, which is in radian. So let's consider the triangle labeled OAB, which is the triangle with blue, one side blue. So let's consider the triangle OAB. And then consider the segment with green boundary or green arc, and I will also call it arc AB maybe, just to be clear. And then the bigger triangle OAC, Now, if you compare the areas of these three objects, you obviously see that the area of this area of triangle OAB is less than the area of the pizza slice is less than the area of the bigger triangle. That's pretty obvious. Now, to find the area of this triangle OAB, I drew the perpendicular line from point B onto the line segment OA. So I call that point BB prime. So you know that the area of a triangle is 1/2 times base times height. So 1/2 times base times height. So in this case, it's going to be 1/2. Base is going to be OA. So we are considering triangle OAB. So OAB. Okay. So the area is OA. By the way, it is a unit circle. So OA is going to be 1 times the height, which is BB prime. Height is going to be BB prime. Now look, if we look at the triangle OBB prime, we note that sine of x is going to be equal to opposite over hypotenuse. Opposite is BB prime and the hypotenuse is OB. Now OB is, by the way, 1, right? So this value is 1. So sine of x is going to be just B prime, which is nothing but the height of the triangle OAB. So this is just going to be sine of x. And OA is equal to 1. So the area, so let's call this one area 1, area 2, and area 3. So we know that area 1 is less than area 2, which is the pizza slice area in green boundary, less than area 3. Now, I just found that the area 1 is sine x over 2 because this evaluates to sine x over 2. Now, let's find the area 2. To find area 2, let me remind you how radian angle is defined. It is defined as radian is equal to arc length divided by the radius, okay? But in our case, the radius is 1 because it's a unit circle. So your angle radian, this becomes actually the arc length. So now to find the proportionate area that is under the arc length or the pizza slice, all you need to do, that is area 2, is going to be, you're going to take the angle x, okay, which is just x, divided by 360, which is just 2 pi, right, in this case, times the area of the entire circle. So from the area of the entire circle, think of it as a pizza. From the entire pizza, you are just taking off one slice. So you are taking the proportionate amount, which is this one. Okay, so area of the circle is pi times r square. R is 1, so 1 square is 1. So now pi and pi is going to cancel out. That's going to give you area 2 is equal to x over 2. So this is going to be less than x over 2. Now let's go ahead and find area 3. To find area 3, which is the area of the triangle OAC, we're going to use the same formula, 1/2 times base times height. Now note that base for this triangle, bigger triangle, is OA. And that OA is actually equal to 1. So this becomes 1/2 times 1 times height. Now height, by the way, is AC. Height is AC. Now look, if you look at the bigger triangle OAC, tangent of theta, or tangent of x rather, is equal to opposite over adjacent. So opposite is AC and adjacent is OA. As you can see, this is the opposite and this is the adjacent. So that gives you tangent of x is equal to just AC. Why AC? Because OA is equal to 1, right? So in essence, this becomes the area of this triangle, bigger triangle OAC, is nothing but 1/2 times tangent of x. Once again, base is OA, which is this side, which is 1. So that's why I have 1 here. AC is this side, the height, which is tangent of x is equal to AC over OA. But OA is 1, so this kind of goes away in a way. So it just becomes that tangent of x is equal to AC. AC is the height, h. So in essence, the area of the bigger triangle becomes 1/2 tangent of x. 1/2 tangent of x. This is obviously clear, right? Just from this diagram. Now, what I'm going to do, I'm going to just add something little here. I could say less than equal to, less than equal to. This inequality is still true, right? So I could rewrite it as sine of x. So let me just use space optimally. Sine of x over, actually I'm going to multiply all sides by 2. Sine of x is less than x is less than sine of x over cosine of x. Since we are in the first quadrant, this is less than equal to. Since we are in the first quadrant, sine of x is going to be positive. So I can divide all three sides by sine of x. That would give me, by the way, 1 is less than equal to x over sine of x less than equal to 1 over cosine of x. Which, if I flip, I'm going to get the following. Cosine of x, that means I take the reciprocal, okay? Cosine of x is less than equal to sine of x over x is less than equal to 1. Now, we are going to take limit of all of them. So, limit cosine of x, limit x approaches 0, cosine of x is less than equal to limit x approaches 0, sine of x over x is less than equal to limit x approaches 0, 1. So obviously this is going to be just 1, right? So nothing to worry there. So this is going to be 1. However, as x approaches 0, cosine of x approaches 1, in the limiting case, cosine of x, limit x approaches 0, cosine of x is going to be just 1. So by using the squeeze theorem, we can conclude that limit x approaches 0 from the 0 sine of x over x is equal to 1. So this is the critical argument here. Using the squeeze theorem, we can conclude that the right limit approaches 1, right limit is exactly 1, and the left limit is also 1. So whatever is in between is going to get squeezed or sandwiched, and the limit of sine of x over x as x approaches 0 must have to be 1. It cannot be anything else. So that's what it is. However, there's a little bit of catch here. The catch is that we considered positive x only. We are in the first quadrant. What if my x is negative? Does this relation hold true? So if we are approaching from the positive side, we are good. Okay? So technically, this could be approaching from the positive side. How about if I approach from the negative side? Okay, approach 0 from the negative side. In that case, does this still hold true? As it turns out that it does. Why so? Because these functions that we are dealing with are what we call even function. What is an even function? Just a refresher. If you have a function f of x, it's called even if f of x is the same as f of negative x. So that means if you replace x by negative x, you still get the same function. That's called even function. Okay, even function. Since we are dealing with even functions here, it wouldn't matter whether I replace x by negative x. Okay, so which is to say, it won't make a difference if I were to approach 0 from the negative side. Now, why are these functions even functions? Because remember, cosine of negative x is the same as cosine of x, okay, and 1 is of course a constant. We don't that's always even function, right? And then sine of negative x over negative x is equal to negative sine of x, because sine of negative x is sine of negative sine of x divided by negative x. Oh, by the way, that is the same as sine of x. Okay, so f of negative x is the same as f of x for sine of x over x. Okay, for sine of x over x, f of x is the same as f of negative x. So it is an even function. So we are good to go. So it doesn't matter whether we take the left limit or the right limit. In either case, we get the same value. So we just showed. So what did we show? We just showed that limit x approaches 0, sine of x over x is actually equal to 1. Now I'm going to go ahead and show you something else. Since we are on the topic, this is another limit worth evaluating, which can be derived from this one using this fact. So limit x approaches 0, cosine of x minus 1. What value does it approach? As it turns out, the value it approaches is 0, by the way. So let's go ahead and do that. So what I'm going to do, I'm going to go ahead and multiply this numerator by cosine of x plus 1 divided by cosine of x plus 1. So that gives me, these are non-zero values, so we are okay. We are in the first quadrant. So that is equal to limit x approaches 0, cosine square of x minus 1 divided by x times cosine of x plus 1. And that is equal to limit x approaches 0, negative sine square of x, because cosine square of x minus 1 is negative sine square of x. Why? Sine square of x plus cosine square of x is 1, and you can solve it. And that is divided by x times cosine of x plus 1. And then I could break it down. The negative sign, I could bring it up front, and it doesn't make a difference. Limit x approaches 0, I could write it as sine of x, and look at this little x there, x. Okay, we just showed it right here that this limit is going to be probably 1. So times sine of x over cosine of x plus 1. So I have written the argument of the limit as a product of two expressions. Now I could use the limits property. So this is going to be limit of the product is the product of the limits, right? So it's going to be limit x approaches 0 sine of x over x times limit x approaches 0 sine of x over 1 plus cosine of x. Now we know that this is 1, so it's going to be negative 1 because of the negative, times as x approaches 0, the numerator becomes 0, right? Sine of 0 is 0, divided by 1 plus 1, because as x approaches 0, cosine of 0 is 1, which gives me nothing but negative 1 times 0, which is 0. So we just derived that limit x approaches 0, cosine of x minus 1 divided by x is 0. This limit and this limit are very important. So please make sure that you remember these two and know how to show them or how to prove them. So what did I do? I showed you that limit x approaches 0, sine of x over x is equal to 1, and used that fact to show that limit x approaches 0, cosine of x minus 1 divided by x is equal to 0. I hope that this discussion was helpful. Thank you very much.